Hello guys, welcome to the last of our interactive labs on electricity. Today we're going to be taking a look at something we've talked about throughout a number of our lessons, but I wanted to give you a chance to formally go over this topic. We are going to discuss open and closed circuits, and in particular we're going to be looking at switches and we're going to be looking at short circuits. So these are two types of open and closed circuits that we're going to look at. And we can build both of those in our interactive. So you'll want to go into our lesson for today. There is an interactive form just like this in the lesson for today, and you can go there and start building. So the first thing that I want everyone to do is to create a simple circuit using a light switch. Let's see, which is right here. There's our light switch, a light bulb, wire, and a battery cell. And just make a really simple, easy to see circuit with all of these things in it. So I'm going to set that up right now so you can see what mine looks like. And make sure again with the light bulbs that you're putting the connections. You need one on the side and one on the bottom. That's one that we've run into a lot for one of our big technical issues with building a working circuit. And we're just going to do this. Real simple series circuit with a switch. Okay, so there we go. There's our thing. Here's a switch. So the first thing you want to do is look at when the switch is up like this. What are the electrons, these blue dots that represent our electrons, doing? Next, you'll want to close the switch, and you just do that by clicking the switch. You can see it opens and closes. So you'll want to make some observations about what the electrons do when you close the switch. And lastly, your last challenge is that I want you to make an open circuit that doesn't have this switch, so you would delete it. And I want you to think of 3 things that you could do to cause an open circuit. So one big hint, I just got rid of the switch right with a big gap, but what are some other things that could go wrong in a circuit that would leave it open and would count as an open circuit? So that's the first part of the lab, and again the switches are right here, and you just open and close them by clicking them, and it'll tell you down here if the switch is open or if the switch is closed. Hey gang, so the next part we're going to talk about is short circuits. So open circuits are one reason that electricity won't flow through a circuit, but there's another reason that this could happen, that your lamp might not light, and that's a short circuit. So a short circuit. In a short circuit, we find out that the power goes somewhere else other than where it's supposed to go. So in this picture right here, we see the power going, instead of going into the light bulb, that X is a symbol for the light bulb, or any other resistor. Instead of going there, for some reason in this situation, you can see that the power is crisscrossing across and totally going around the light bulb. Well, this happens because electricity is lazy. It's always going to take the shortest, easiest path to get where it's going. Just like me, I like taking the shortest path, for instance, to walk from my car to get into the grocery store when I park. Electrons feel the same way about things. So, a few things that can cause a short circuit could be wires that are older might lose the insulation, that rubbery part as we know it, or in the older wires it was paper or fabric that's on the outside of the wire. And then maybe the wires will touch each other and we'll get a short circuit. Another possibility is there could be just bad wiring. Another one could be intentionally connecting the positive and negative of the battery together. And you guys have run into this a lot because that's when we see fires frequently. Short circuits are a big cause of fires. They make it so whatever electrical device you want to use doesn't work. In your house generally has a circuit breaker that's a fuse, and that will trip and prevent the fire. So sometimes a short circuit will cause a fuse to trip and your circuit doesn't work. And that's a good thing in that case because it's preventing a fire. Or the short circuit might just make the thing not work in general. And I guess that's the lucky one because there's no fire, but it's still broken. And of course, broken isn't any good. So the challenge here is I want you to cause a short circuit. You will know that you have a short circuit when some piece of your circuit catches on fire, or if you use a fuse, the fuse snaps and prevents the fire, either one. So I want you to find out how many ways you can short circuit your wiring. Document them wherever you're keeping your science notes so you have that. So let me show this to you quickly. Find my old screen. Let me get that up. So to do that, you can either use the circuit you were just using for switches, right, to cause the short circuit, or you could make a new one, either one. So you are going to know if the electrons are flowing really quickly, there's a good chance you have a short circuit as well. So if I did bad wiring, for instance, I mentioned that would be a cause. I might go like this. And do you see how fast my electrons are going? That's the first sign there's a bad thing. This must still be getting some electricity because it's still lit up a lot. That part surprises me, but not very much is going through because all of the electrons are just cycling as fast as they can without getting a resistor to slow them down. We get a fire. So there's a lot of ways you can go about creating a short circuit. Now, I know some of you have been playing with the fuses, so if you are curious about how to prevent a fire in a short circuit, try out a fuse. So let me disconnect this wire, and in place of the wire, I'm going to put a wire and a fuse. So let me move some stuff down here so we have a little more space. So I could put the fuse in to protect us from a fire if a short circuit happens. So another sign of a short circuit right here, my fuse tripped and electricity is no longer going through this wire. Luckily in this case it fixed the circuit, right? So the electricity is flowing back through the light. So you can play with fuses and see just how many things you can do to make a really poorly designed circuit on here. Some of them, things like insulation being off the wires, we can't do, but you can create some really complex ones. So the things you want to look for are electrons that are flowing really fast. Again, that will look like this, and you'll probably get a warning about the animation speed. You can look for fire, and you can look to see if the fuse looks like a closed healthy fuse, which this does right now, or if it's snapped in the middle. If it's snapped in the middle, you had a short circuit and your wiring protected you, which is always a good thing because like I said that's how we prevent our houses from catching on fire. So that snap immediately. So that's what I want you guys to do today in lab. Enjoy, happy playing with circuits, and hopefully you've enjoyed this electricity unit and gotten a chance to apply some of it with the circuits kit that was sent to you by K-12.